Welcome back to the lecture series in bioenergy. So, the previous class, if you remember, we started with the different forms of gasifiers. So, we talked about the classification of gasifier types, and there we talked about the fixed bed gasifier, fluidized bed gasifiers, as well as entrant suspension gasifiers. And further, we classify them under these three heads to the different types which are available. So, if you recollect, in the last class we talked about the fixed bed, and within the fixed bed we talked about the three different types: updrift, downdrift and cross flow. And previously we have covered the updrift. So, today what we will do, we will talk about the downdrift design and the cross flow design. Okay. So, before we get into the gasifier anatomy, let us again revisit the updrift gasifier, where you can see that the biomass is inserted from the top, okay, and the air is coming from bottom. So, what is essentially happening, air is moving in the upward direction, updrift. There is a drift of the air which is moving from bottom to up. So, if we have to talk about downdrift, then it should be reversed, right. So, the air should move downward, okay, instead of moving upward. Now, look at another interesting aspect into it, where I showed you the graph. You see the temperature, how it is varying at different zone. At the drying zone, you see the temperature is around 200 degrees centigrade, okay, degrees centigrade. This is the temperature scale, okay. Whereas the gas which is coming out of it, out here, so look at it, that is coming out at 200 degrees centigrade. And we talked about it, if the gas is coming out at a lower temperature as compared to the combustion and gasification temperature, it is, the system is generally much more robust and much more efficient. Keeping this picture in mind, now from updrift we will move to the downdrift gasifier, and let us start with the schematics of the downdrift gasifier. Downdrift gasifier, okay. Exactly, we will follow the same protocol what we followed in the previous class. First of all, we will have the schematic in front of us. So, that will kind of give you a visual feel how it looks like, and I request you, whenever you get chance, you should visit where these kind of gasification plants are there. This will be a very good experience for all of you to look at, that how much of these things work. Okay. So here you have, so it is not by scale. So this is the air port, which is port for air entry, okay. And this is okay. Okay. Now, this zone, if you remember, this is where you are introducing the biomass. Okay. So, this is the biomass introduction zone, and from here the gas is escaping out. Okay. And this is the port through which air is being pumped into it in order to promote the combustion process, combustion pyrolysis and all other processes. And just above it, above this port, the region what you see out here, which I am now shading. Let me use a different color for better understanding. This is where you are having the drying zone. Okay. And underneath it, out here, which I will be putting in green, something like this, okay, and there is one small partitioning out here. Okay. So, this is the drying zone and this is the drying, and this zone what you see out here is the volatilization zone, where the volatile materials are getting escaped, and here is the combustion zone where the combustion is taking place, and underneath it you are having small kind of partitioning which is being done, something like this, and likewise, and on the other side also you see in the combustion zone there is a port is taking care of it. So, what is happening is that air is coming like this. So, instead of, if you compare this figure, and just let me finish the drawing. So, here you are having the reduction taking place, and underneath where you are having the ash which is getting accumulated because of the charring process. Okay. Now, if you compare this picture with the previous picture which was the other gasifier updrift we talked about, you see the air is moving out here and it is moving all the way into the top. Here if you look at it, air is not following that route, air is coming into it and moving down, and that is where the reduction is taking place and ash is getting accumulated here. So, in other words, here the arrow will be like this. What does that mean? That means feed and the air move in the same direction. Point 1 for your take home message will be feed, which is basically the equivalent to biomass, feed and the air moves in the same direction. That is, both of them are moving downward. That is why we call it a downdrift gasifier. And if you compare the temperature as we did previously, here is the temperature plot what I will be drawing now. Let me put the scale. So, we have the 200 which is the lowest, 200 degree centigrade, all are in degree centigrade, okay. 600, here you are having 800, 1000, 1400, okay, all in degree centigrade. And if you map it, the way temperature is changing out here, the mapping is very interesting. It starts at around 200 degree and then it moves all the way during the combustion zone, it almost hit this kind, but the temperature at which it is coming out, the gas is coming out could be something like this. So, if you look at it, so look at carefully in the graph. So, you see it started at drying started at 200 degree centigrade. Okay. As is going down, this is the zone where temperature is kind of the highest, where we are talking about between 800 to 1400. But the gas which is coming out is also at a higher temperature. Unlike if you compare this with the previous one, updrift one, you see when the gas is coming out, it is kind of at a lower temperature. As compared to here, what you are saying is that, just for your understanding, I am doing it, do not get confused. Here what is happening, it is happening more like this. So, there is a shift in the downdrift and this is the updrift. Okay. So, DD stand for the downdrift gasifier. So, in the downdrift, that blue line is shifting more towards the left. So, more towards the high temperature. Okay. So, now coming back, so the first characteristic about it is that in the downdrift gasifier, what we are having, the gas which is coming out is at a higher temperature. So, what is the second salient point about this is that the product gas leave the gasifier, the product gas, or which is your actual product you are looking for, leaves the gasifier unit at a temperature T degree centigrade or around 900 degree to 1000 degree centigrade. Thus, as I mentioned in the previous class, thus the overall efficiency of the system is low. Overall efficiency of the DD stand for downdrift, DDG stand for downdrift gasifier, DDG is low as compared to updrift. So, this is the first take home message. The downdrift has a lower efficiency and due to high heat content carried over by a lot of hot gas, carried over by a lot of hot gas. So, keep this aspect in mind. Second thing, there is a very interesting trade off which happens. The tar concentration which is produced here is low. Tar really goes down, but here is the catch. Though you are reducing on the tar because it is getting more time. Why? Just you have to ask this question, why you are having lesser tar? Because if you look at the situation out here, because of persistent maintenance of a higher temperature, lot of tar molecules kind of gets broken down. So, look at this region. So, you can have the graph a little bit more shift like this also. So, this is the zone where lot of tar is being taken care. This is the zone. Okay. One second, let me. The yellow hatching what you are seeing is the where the tar is being taken care. But having said this, always have to remember particle concentration is higher. So, on one hand you are getting a better or rather lower tar level, but you are simultaneously increasing the particle concentration. So, it is always a very big trade off what you are doing. Okay. And there is a huge amount of ash which is created in the system. Okay. So, this is the fundamental difference if we have to talk about updrift and the downdrift gasifiers. These are the two basic gasifiers which are being used. There is a third type which we will be discussing now, which is called the cross flow gasifier. So, just to understand, if you look at it, so what is happening? Gas is coming out at a different level, air is coming at a different level. From here, air can either move up, of course, if the air chamber is somewhere out here, then we call it updrift gasifier, UDG. Okay. And if the air is moving in this direction along with the movement of the feed, then we call it downdrift gasifier. But here realize that this is at a different level, the gas emission and the air is at the different level. The ejections are happening at a different level. Now, think of a situation. If we say both gas and air, they are getting out and getting it at the same level. It is kind of a crisscrossing each other. So, let me just draw the gasifier, that will make more sense to you people what we meant by cross flow gasifier. Okay. So, cross flow gasifier. So, the schematic of cross flow gasifier is something like this. Okay. Okay. So, here is this is the entry port for air, and at the same level you have the exit port for the gas. Okay. And the way, and this is the feeder from where you are feeding the biomass to the system or the biomass feeder, and the first level is your drying region. One minute, let me. Okay. So, the first level what you see will be the drying region where biomass is getting dried up. Next is the distillation zone, which is putting a different color for your better understanding. So, which is something like okay, now okay. So, this zone what you see, which I am now using violet color to hatch the zone, this is called the distillation zone. Distillation zone. The region which is out here, just where I am putting yellow coloring, I am doing. See, follow my yellow coloring shade, horizontal, vertical lines what I am drawing. This is the reduction zone. Okay. And out here, what you are seeing is the burning char. This is underneath is the ash pit. Okay. And we have talked about the reduction zone, and this particular part is called the, you remember in the previous class we talked about the hearth. This is the hearth zone. This is an example of a very classical gasifier with a cross flow anatomy. Okay. And so, this is what is the highlighting feature of this whole thing, same level. So, there is a cross flow happening at the same level. Unlike the other ones, if you follow that either both the gas port and the air port are at different level, whereas here both the ports are at the same level. It is just air is coming out and gas is going out like this. Okay. So, this is the classic signature of a gas flow, cross flow gasifier. Okay. So, now what we will do, we will write some of the basic characteristics of the cross flow gasifier. So, in this situation, the feed or the biomass or the feedstock, feed moves downward. As you could see, the feeder is at the top. So, essentially feed is moving downward. Okay. Feed moves downward while the air is introduced from the side. Okay. The gas being withdrawn, the gas being withdrawn from the opposite side of the unit at the same level, withdrawn from the opposite side of the unit at the same level. This part is very important for you to remember, the same level. This is the fundamental difference with other gasifier types or fixed bed gasifier what we have talked about. Hot combustion or gasification zone form around the entrance of the air. A hot combustion slash gasification zone forms around the entrance of air, forms around the entrance of air. That you can verify if you look at the picture very carefully, you will see. So, this is where what we are talking about. So, the air is entering out here, and this is where lot of the reactions which are taking place, the reduction zone. Okay. So, now at the entrance of air, okay, with the pyrolysis and drying zone being formed, with the pyrolysis and drying zone being formed higher in the vessel, being formed higher in the vessel, higher in the vessel. So, that also you can verify by looking at the picture. See, this is the drying as taking place at a higher level. Okay. Similarly, distillation or pyrolysis, all what is happening, all is happening at the higher level, and at this level the final reaction where the air is coming in contact with those processed stuff. Okay. The third critical point is, and this is, ash is removed at the bottom. As you could see, there is an ash pit. If you recollect the figure again, so you see there is an ash pit from where you are recollecting the ash. Ash is removed at the bottom, okay, and the temperature of the gas leaving the pit, of the gas leaving the unit is fairly high, just like the downdrift one. Leaving the unit is about 800 to 1000 degrees centigrade. Thus, what you are getting in such a situation is that the system has low efficiency and this gas has higher tar content. Why is it so? If you look at the anatomy carefully of this reactor, you will realize it, because this is the only zone where most of the reaction is taking place. So, there is no other way you can remove the tar. Okay. So, it is not really falling down, it is at one specific location it is taking place. So, you really cannot remove the tar. So, tar concentration is higher and the gas which is coming out, that is hardly getting any time to travel through, the gas is at a very high temperature. So, that reduces the overall efficiency of this kind of, like the cross flow gasifiers what we have been seeing. So, let us summarize. We talked about where air is moving from the bottom going up. We talked about air is moving from up is going down, downdrift. You have the updrift, you have the downdrift, and you have the cross flow like this. Air is coming and hot gas is going, and they are at the same level. So, these are the three classic fundamental fixed bed gasifier what you needed to know. On top of this, several modifications have been made depending on different parts of the world where different kind of biomass is being obtained, either with higher moisture content or higher tar content and whatever. You know, there are so many parameters what we have already discussed. Based on that, the gasifiers are being modified all over the world. So, next what we will do after this, we will talk about the efficiency of these fixed bed gasifier. So, I will close in here. Okay. Thank you.